Returning the asteroid into the Earth-Moon system basically consists of taking its flyby of the Earth-Moon system that would occur anyway, because generally these objects are in an orbit around the sun that brings them near the Earth every so often, every few years, anywhere from 2 to 10 years. They basically lap the Earth like a race car lapping another race car going around a circuit. And so if it's in an orbit closer to the sun than the Earth, then it will go faster than the Earth and lap the Earth from behind. And if the Earth is orbiting inside it, the Earth basically laps it from inside. So the process of putting it into the Earth-Moon system is basically to just use the solar electric propulsion to nudge the asteroid to the point where it does a close flyby of the Moon and goes around the leading edge of the Moon. So if the Moon is going around the Earth like this, you come around the leading edge, and basically that's a slingshot maneuver, which very much like a tennis racket hitting a ball, you can add twice the speed of the tennis racket to the speed of the ball. And because of the elastic rebound, you get 1 unit of speed coming in and then another unit of speed as you bounce off. And so that same principle allows us to kill off up to twice the orbital velocity of the Moon going around the Earth. So the Moon has an orbital velocity of about 1 kilometer per second going around the Earth. And so as we do this slingshot maneuver around the leading edge of the Moon, we can kill off up to about 2 kilometers a second of excess velocity and thereby capture it into the Earth's gravity well. And so we can tolerate objects, we can capture objects by that technique, objects that are moving as much as 2 kilometers a second with respect to the Earth, that would have passed by the Earth at a speed of 2 kilometers a second. But instead, because we do this slingshot maneuver around the front of the Moon, we capture them into the Earth-Moon system, and that it takes a while, typically a year or so, to get them into what's called a distant retrograde orbit, which is an orbit around the Moon. Again, if the Moon is going around like this, it's an orbit around the Moon that is so-called retrograde, which means it's an opposite direction from the normal direction that everything in the solar system orbits. All the planets go around the sun in the same direction. All the moons go around the planets in the same direction, but with a couple of exceptions. But this would be in orbit around the Moon in the opposite direction. That's a very stable orbit. So it's an orbit that's guaranteed not to have the asteroid crash into the Earth if we lose control of it.